So now let us learn about increasing and decreasing functions. So to learn about increasing and decreasing functions, let us take this graph where you can see on the screen. So looking from the left, we see that the graph is going upwards. The graph is increasing, and above x equal to -2, we see that there's a point on the graph where the graph neither increasing nor decreasing. So it is a point in between, from increasing to decreasing. So that point is the maximum value on the graph, or you can call it the maximum value of the function is at x equal to -2. Then the graph starts going downwards. It is decreasing, and at x equal to 3, below x equal to 3, you see that the graph, there is a point on the graph where the graph neither decreases nor increases. So that is the point on the graph where it is the minimum value, or you can call it that the minimum value of the function is at x equal to 3. Then from there, you see that the graph is going upwards again. It is increasing. So what we do is we will use the intervals. We only look at the x-axis now. Now we see like this. From -infinity to our extreme left to x equal to -2, we say that the graph is increasing. And from the interval -2 to 3, this is the interval where the graph is decreasing. And the interval from x equal to 3 to +infinity, this is the interval where the graph is increasing. So it is very easy to learn about increasing and decreasing functions if you have a graph like this. But there is a problem. During exams, you will not be given a graph, and you will not have the time also to draw the graph, but because it takes so much time to draw the graph. So what we do is we will solve this problem. We will find out the intervals where the function is increasing, where the function is decreasing, where the function is increasing again, simply using mathematics. And in particular, we will use the derivative. So how will we do that? Remember, during exams, you will not have the graph. For now, you understand simply from the graph. But during exams, you have to simply depend on your calculations, and that also using the derivative. So to do that, we start with a given function. Say the given function now, it is f of x equal to 2 times x cubed minus 3 times x squared minus 36 times x plus 7. So this is the given function. Now imagine you are given this function and you don't have the graph in your hand. And drawing the graph also will be so difficult during exams. So what we do is we will use the derivative. We start like this. First, you find out the derivative of the given function. So f prime of x, that is the derivative, shorter notation of a derivative. So this is a derivative of the given function with respect to x. So f prime of x. Now when you have got the derivative, then what we do is we simplify that. When you simplify, like in this case, you'll be getting 6x minus 3 and the bracket and x plus 2 and the bracket. Always you have to do like that. Now, remember in the graph, there is a point where the graph neither increases nor decreases. So at that point, f prime of x is equal to 0. Why it is equal to 0? Because we know that f prime of x is the slope of a tangent. And the tangent at that point is horizontal to the x-axis. So because it is horizontal to the x-axis, the slope of the tangent should be equal to 0. Now we can understand that whenever you have a maximum value and whenever you have a minimum value on the graph, then f prime of x must be equal to 0. Because at those points on the graph, the tangents will be parallel to the x-axis. So now when you equate f prime of x equal to 0, what we do is we are trying to find out those values of x where you may get a maximum value or the minimum value of the function. So like in this case, when you equated f prime of x is equal to 0, then you get x is equal to minus 2 and x is equal to 3. Then you understand that the graph will give you maximum value or minimum value in these points. So to find out that, what we do is we will take any value between minus infinity and minus 2 and put that value in f prime of x. Put that value of x in f prime of x. And we will observe whether f prime of x is greater than 0 or less than 0. If it is greater than 0, then the graph is increasing. If f prime of x is less than 0, then the graph is decreasing. And we will do the same thing in the interval minus 2 and 3, interval 3 to infinity. So by solving f prime of x equal to 0, what we get is, finally we get 3 intervals now. Minus infinity to minus 2, minus 2 to 3, and from 3 to plus infinity. Now, let us check in the first interval from minus infinity to minus 2. You take any value between minus infinity and minus 2. Say you can take minus 3, minus 4, minus 5. All these values, they are less than minus 2. And that value which you have picked up, substitute in the expression which you have in f prime of x. And check for the sign, only for the sign. Don't check for the value, that real number, check only for the sign. So in f prime of x, we have two factors, x minus 3 and x plus 2, which will determine the sign because the other number is already a constant, which is positive. So when you take any value between minus infinity and minus 2, we find that the sign of f prime of x is positive. So the graph is increasing in the interval of minus infinity and minus 2. So the same you do in the interval minus 2 to 3. Take any value. So you can take minus 1, 0, 1, 2, so on, and put that value in the expression of f prime of x and only check for the sign. In this case, you get a negative sign. So you understand that the graph is decreasing in this interval. So like that, we solved the problem.